we observe that when we set up a circuit with the generator and a large capacitor, of course the generator has a small resistance, and that's the only resistance in the circuit. It actually has a fairly significant resistance. In any case, when we set this circuit up with a voltmeter in parallel across the capacitor and start cranking, the experience is different than if we set the circuit up with the voltmeter in series across the capacitor, across the source. Okay, just a series circuit where all the electrons all the current goes through the voltmeter and ends up being stored in the capacitor. There's a big difference between the way these feel, and you might want to review what that difference is. And we're going to try to explain that difference. So if we have this situation, essentially the generator has a negative side which pushes electrons away from it, and a positive side which attracts electrons. Okay, so if we think of what's going on, we have the capacitor here, and we're going to be pulling electrons off of this side into the electron sucking side of the generator, and pushing electrons onto this side from the electron pushing side. So we're going to have an electron flow around the circuit in this direction. Now that means that we're going to have a conventional current in this direction around the circuit. There's a large resistance across the coil of the galvanometer. As a result, the galvanometer, or the voltmeter, is not going to pull very much current. So most of the current that flows is going from one plate of the capacitor to the other, essentially. As a result, of course, this side of the capacitor loses electrons progressively, so it increases its positive charge. This side gains electrons progressively, increasing its negative charge. As the charge builds up on the capacitor, we get a voltage across the capacitor. Now if we have an electron here, it's going to be pulled toward the capacitor, and it's also going to be pulled toward the source. Now as long as the source is pulling harder than the capacitor, we're in good shape. We're going to continue having an electron flow. But as the charge on the capacitor builds and builds, we're going to get a stronger pull in this direction, and eventually the charge in the capacitor will be effectively as large, the pull of the capacitor will be effectively as large as the pull of the source. And at that point we're going to stop building up charge in the capacitor. Another way to look at this, of course, is that we have a voltage here that's trying to push conventional current around in this direction. That's the source voltage. As the capacitor builds charge, there's a voltage opposing the source voltage. The capacitor is trying to push positive charge around this way, so that the two oppose each other. As a result, as the charge on the capacitor, as the voltage in the capacitor builds, there's less voltage across this resistance. Okay? The net voltage across this resistance is a difference in the voltage from the source and the voltage from the capacitor, which are fighting each other. So there's less flow in the circuit, and charge builds up on the capacitor more and more slowly. Now we observe this. As we crank the capacitor, the charge builds up more and more slow. The voltage builds up more and more slowly. Now, what's the voltage across here indicating? The voltage across here indicates the voltage across the capacitor, of course, which is just the charge divided by the capacitance. So that as we build up charge, naturally we get a greater voltage across the capacitor, and that's what we're reading here. So we got some words here, and you see these words on your document. But as the charge in the capacitor increases, opposition to the action of the source increases, and as a result, current decreases. And that's what's going on there. Now, what happens in this case? Well, we've got this small resistance here, we've got a large resistance here. What happens when we start cranking is not much current flows. There's very little current flow here because there's a large resistance. Now, how does that feel when you crank it? You might want to go back to your notes or recall what it felt like. But that certainly has definitely a different feel than this situation when you crank it. What do you read on the meter here? Okay, what's the reading on the meter indicate? So you might want to think about that. There's a distinction between these two cases, and if you think that through, you'll gain some insight.